In this example, we will find the Thevenin equivalent circuit at terminals A and B. Now, we've done this problem in another video, but we're going to use source transformation to hopefully make our circuit a little easier to analyze. So the first thing we're going to do is find the open circuit voltage between A and B, which of course is the Thevenin voltage. Now when we look at our circuit, there's a 15 amp current source in parallel with a 20 ohm resistor. And when we have a current source in parallel with a resistor, we can change or transform that current source and parallel resistor into a voltage source in series with that same resistor. So I'm going to draw that down below. Here's a voltage source, and that voltage source will be put in series with the same resistor, 20 ohm resistor, and the value of the voltage source is going to equal the current source times the resistor. So 15 times 20 is 300. The voltage source is 300. Well, we got a 20 ohm resistor, so there's the transformation. And then there's the 5 ohm resistor still there. And the second 5 ohm resistor. And there's terminals A and B. Now this equivalent circuit is a series circuit. 300 volts in series with 20, 5, and another 5 ohms. So the open circuit voltage, which is the Thevenin voltage, can be found by voltage division. The open circuit voltage between A and B is the same as the voltage across the second 5 ohm resistor. And so using voltage division, VOC is the 5 ohms over the total resistance that's in series, which is 30 ohms, times by the total voltage, which is 300 volts. And when we do the math, VOC turns out to be 50 volts, which is V Thevenin. Now, to determine R Thevenin, what we'll do, since this circuit only has independent sources, we'll just kill that source and find the resistance between terminals A and B. So we'll actually use our redrawn circuit with the 300 volts. We'll kill the 300 volt source, which basically means we'll replace it with a short. Leave all the resistors in. And so we're left with a 20 ohm resistor in series with a 5 ohm resistor. And that combination is in parallel with another 5 ohm resistor. So if we determine the resistance between A and B, we have 25 in parallel with 5, which is 25 times 5 over 25 plus 5, or 125 over 30. So R Thevenin is 4.17 ohms. So the Thevenin equivalent circuit can be redrawn as one voltage source of 50 volts in series with a 4.17 ohm resistor. So this would be our answer. 50 volt source in series with a 4.17 ohm resistor.